This is Algebra, lesson, actually investigation 6, and it's on transforming linear functions. So a linear function is the function of that the graph is a line, and so a parent function for a linear function is f of x, so f is the function of x equals x. I would like you to recall the slope-intercept form of an equation. So this is the form of an equation where you can tell if you have y equals that this m stands for the slope and b stands for the y-intercept. So when it's in this form, it's very easy to graph. It's very easy to see the slope and what the y-intercept is. So the parent function of is just f of x equals x. So that means the slope is 1 over 1 and the y-intercept is 0 or 0, 0, which is the origin. We're going to graph that one in just a moment. Translation. So transforming linear functions, we need to know what is a translation. It is where we shift every point in a figure the same distance in the same direction. So for example, a vertical change is a translation. So that's what we're going to look at with number 1. Number 1, we are going to graph the parent graph, which is f of x equals x. So let's do that first before we move on. So we're going to begin with the y-intercept, which is 0. So this is the y-axis and this is the x-axis. Now the slope is 1 or 1 over 1, which means it's the rise over run is 1 over 1. So it goes up 1 over 1. It is a positive slope. It would go down 1, back 1, because anytime you have, it's also equivalent to negative 1 over negative 1. So here's our line of the parent graph. So the parent graph is a positive slope, starts at the origin, goes up 1 over 1, up 1 over 1, and continues. Okay, so now we're going to graph f of x equals x plus 3. I always start with the y-intercept, so here the y-intercept is 3, so it'd go 1, 2, 3. And then the slope is the same as the previous parent graph, which is 1 over 1. So I'm going to go down 1, back 1. I'm going to go up 1 over 1. So it should be that these lines have the same slope going the same direction, but the y-intercept is what has changed. And then the last one they want us to graph is x minus 2. So that means that the y-intercept is negative 2. So 1, 2. The slope is the same, up 1 over 1, down 1, back 1. So the slope is the same on those. Okay, so then we have 3 lines. And the question that they're asking us is, how has the f of x equals x plus 3, how did this graph change from the parent graph? Well, it changed because the slope is the same, but the y-intercept changed where it shifted 3. So we're going to explain that and answer it by saying that the graph of f of x equals x plus 3 shifts 3 units up from the parent graph. The y-intercept shifts from 0, 0, which is the origin, to 0, 3. Okay, so that is explanation of numbers 1 and 2. Number 3 is we are asked again to graph the parent graph of the linear function f of x equals x. So I went ahead and did that. The x-intercept is 0. It starts at the origin. It goes up 1 over 1, up 1 over 1, positive slope. So this is always the graph of the parent function f of x equals x. Okay, so now we're going to graph f of x equals 3x. So again, I want to draw your attention to remember that y equals mx plus b. This is going to represent the slope, and this is going to represent the y-intercept. And so looking at this, 3x, the slope is 3, and then there's no y-intercept. So that means it begins at the same point as the parent function. The intercept is 0, or the origin. So let's go ahead and graph this one. So it begins here, and then the slope is, the rise is 3, and the run is 1. So it's rise over run, so you'd go up 3, 1, 2, 3, and over 1. And so then the same would be true, because -3, if it was negative over negative, -3 over -1. So you go down 3, 1, 2, 3, and back 1. So you'll see that this line is much steeper than the original. It's still positive, but it's much steeper. Okay, so then let's take a look. Well, let's summarize that actually. With number 4, it's asking us, what is the difference? What happens when you increase the slope of the parent function? So when a positive slope increases, the line is steeper than the original being the parent function. So this first sentence is describing what happens when we increase the slope, and the slope increased to 3 this time. So then let's go ahead and draw out this function, f of x equals 1/3 x. So now we're decreasing the slope. It's still going to be positive, but it's going to be much less now. So this function, if I were to write the y-intercept, it would just say plus 0, because if it's not there, it's 0. So again, we're going to start at the same y-intercept 0, but this time the rise is 1 and the run is 3. So you see this is going to be much flatter. So if I start here, I go down 1 and then back 3. So then this line is, let me try that one again. This line is much less steeper than the original. So let's see if I can see better. Here's the original. And then we have where I increased the slope, and then we have where we decreased the slope. So you can see it's less. Okay, so that's this one, whereas the blue, which is steeper, is this one. Okay, so let's summarize that. When a positive slope decreases and stays positive, it is not as steep as the original parent function. Okay, so that's numbers 1 and 3 of this investigation. Okay, for number 6, we're going to graph f of x equals 4x, and then we're also going to graph f of x equals -4x. So the difference is going to be a positive slope, 4 over 1, versus a negative slope of -4 over 1. So let's take a look at that. Rise over run. So we're going up 4, 1, 2, 3, 4 over 1. I start at the origin. I have to remember to say that because if I have just 4x, it means it's 4x plus 0, 0 be the origin. So I go down 4, back 1. Okay, so this is going to be a very steep line, and this is representing f of x equals 4x. It's a positive slope going up from left to right. Now let's go ahead and graph this one. It's -4x. I start at 0, the y-intercept is 0, so I go down 4 and then over positive 1. So I go up 4, back -1, and then I get a negative slope. It's going left to right, so this is f of x equals -4x. So the result here, here's our conclusion, is that graphing the original line with the opposite slope, so this one was positive, this one's negative, so the opposite slope results in a reflection over the y-axis. So if you look at this first one, then you look at the second one, you'll see that they are mirror images of one another. Okay, so that is a reflection. Let me make note of this right here. Reflection produces a mirror image across a line. In this case, it was the y-axis, and I suppose you could call it a flip. It's a mirror image. Okay, now I'm going to graph number 8 is asking us to do f of x equals x. So again, that's the parent function. So I start at 0, I go up 1 over 1, draw in my line. Okay, and then I'm going to do f of x equals 3x plus 2. So this one has the y-intercept of 2. So I'm going to start at positive 2. And then the slope is 3 over 1, so the rise is 3 over 1. So 1, 2, I would go up 3 over 1, and then I'm going to go 1, 2, 3, down 3, back 1. So then this line is going to look something like that. So summarizing this final one, this is our parent line, and then this is the new one. So the line of y equals 3x plus 2, which is this one, y or f of x equals 3x plus 2. It's steeper than the parent graph. So looking at this one, see how it's much steeper, goes up much more drastically. And then it is also shifted up from the graph of y equals x, or I should write f of x. Okay, that's the parent graph. It's shifted up 2 units. So it's shifted up 1, 2, and then it's much steeper. So that helps, that's a description of how has it changed, what has been transformed. So this whole lesson has been on transforming linear functions. How does the equation of the function change the graph from the parent function?